transformer ratio. For every clamps we need to see to enter its transformer ratio. But for this very high current clamps, transformer ratio is equal. They all have the same ratio, 3000 to 3. So somebody entered it before us. So it's very simple. For smaller clamps, they were tested at the manufacturing and they are calibrated, so they have different ratios. For example, 399 and here 398.2. They have different transformer ratio, and of course, because of it, they should be numbered. If we set ratios for first clamps, second clamps, we should use them as first and second, not change them. And what do you think? Why we have two different numbers here, two lines?
Max, binary, and secondary.
Of course, this is primary, this is secondary, but what about this one?
Maximum, max mean.
The input and output.
Voltage, current max 4.
399, 40.
No.
Is it the output? The input and output?
They both input, output.
Yeah.
Primary, secondary on both of them. But why we have two different transformer ratios here? Because this clamp has two different ranges.
Okay.
10 ampere.
For 10 and for 100 amperes. Yes, we have two different ranges, and of course we need to use proper range because otherwise we can get measured values 10 times more or 10 times less than we need.
Okay.
So we can take incorrect values. So I told that this is the main characteristics of clamps, and it should be entered carefully. Well, for current clamps we entered it, and also we have some numbers for voltage input. And what can of course you see that primary and secondary equals 1 here, but for what reasons we use it, and when can we use it? I cannot see any transformer and any transformer ratio at these clips. So for what reason they place it these fields here, which we can change, which we can set up. In which case we can or we should change these numbers, not one. If we will measure some, for example, high voltage network, let it be 10 kilovolts. If we perform measurements at 10 kilovolts network, of course we cannot connect these clips to cables or to bars at 10 kilovolts. First of all, because of safety, because we will be killed, and the second reason is where is it? Maximum 660 volts, 600 volts. So we cannot connect it to 10 kilovolts. But of course, any substation has measuring transformers where it is designed for voltmeters. So in most cases it gives at secondary side. It gives voltage about I think 100 volts. Of course, I may mistake, but I think I may be wrong, but I think it's 100 volts. So 10 kilovolts. If we have 10 kilovolts, this measuring transformer gives 100 volts. And of course, we have voltmeter, which measures from 0 to 100 volts, but its scale is graded up to from 0 up to 10 kilovolts. So it measures 100 volts, but it shows us up to 10 kilovolts, and we have a real value measured at its display. So we can, in this case, if we have measuring transformer, we can connect our clips to secondary side of this transformer. We can measure this value, and in this case we can place here, for example, from 10,000 to 100 volts. So in this case, these two, for it does not matter if this transformer is placed here, or maybe here, or maybe we connect it to this transformer. It knows that this transformer ratio shows to it that data on these two wires is divided by this transformer ratio. Now it is not divided, it is 1 to 1. But if we will use transformer, external measuring transformer, let it be from 10 kilovolts to 100 volts, we will enter 10,000 to 100, or the same 100 to 1, of course. We know mathematics.
Yeah.
Yes.
Yes.
So and in this case, it will measure value, and it will multiply it 100 times, and it will measure 100 volts, but it will show at diagrams 10,000 volts. And what I told about space, some students asked, for what reason, why we need space if we have no letters, we have no right anyway. But in some cases, for example, I need to enter 1 to 1 here, for example. So I can simply and I can type 1.0, or I can type simply 1. It's the same. It will work. It will recognize it.
Okay.
So 3, 10, 10, 10, 3,000.0. Okay, now we have entered 3 channels for current, 3 channels for voltage. We have entered transformer ratio for current, and we are sure that we have 1 and 1 for voltages. Okay, now we can store it. What is default? Oh my God!
Default is 1
this button. I did not remember it, but this button resets to factory default. Okay, 3,000. Let it be 3,000 to 3. Yes, 3 point. Now current, voltage, 3,000. and 3. Store. No, escape. Yeah, it was saved. Now we have settings for channels, and next important item in menu is global memory setup. In some versions of firmware it was called buffers setup, because all memory is not subdivided but called by some buffers. Look at this global memory setup. We can see memory A, or in manual it is called buffers of type A, B, C, D, E. This does not mean any physical subdivision of memory. No, it is not some different areas with fixed size in memory. No, it has common memory, but this is not different variables or array of parameters. No, A, B, C is type of settings for memory, and as for me, it is good idea. This realization of memory settings. Look at this. Memory A. This is only, once again, this is only type of settings. Memory A is mean time 10 minutes. I can set from one period, for example, I can set space. One minimum time is 1 minute. How can I change unit of time? Select. When we cannot enter numbers, when we need to change some values, like units or like checkbox, we use select soft case. Select period, second, minute, hour. So, for example, we can measure even every period. This is
one period.
Yes, one period or 20 milliseconds.
Yeah.
Yes, one period of frequency is
15,
yes, it's 20 milliseconds. This is a minimum, so it can get average value every one period. It's once again, it's cool. It's very old, but it's cool because as I have seen, most of modern devices use minimum value is 1 second, because they think that standard requires to perform measurements with averaging every 10 minutes. So they think 1 second is much lower than 10 minutes. So of course we can use standard value or standard value 10 minutes, but if we need more frequent measurement, more frequent averaging or lower interval of averaging, we can use not 10 minutes but 1 minute or 5 seconds or 1 second. They think that 1 second is a very short interval and it's enough, and it does not it is not necessary to measure more frequently. But once again, of course, for energy consumption, for monitoring of power consumption, yes, 1 second is not necessary. 10 minutes, maybe 1 minute, but commonly 10 minutes. But for our experiments, in some cases, when we need to analyze, we performed such experiments like measuring inrush current of motor drives or switching on current of fluorescent lamps. In this case, we maybe we need to measure even one period, because measurement is very short. We can measure about 10 seconds or 20 seconds. So we can measure 10 seconds with averaging time, with mean time, every one period. Of course, we will not measure every period if we perform, for example, 1 day measurement, because it will be very big volume of data. But in some cases, 1 period is necessary for us, for our experiments. Next, length of this buffer, of course, it's clear.
1 day.
Yes, now it's 1 day, but we can set it once again from 1 to about 900. No, 9,999 what hour, period, second, minute, hour. So maximum is so long time, many hours. Yes, we cannot set it as days, 3 days, 7 days. So we need to calculate, for example, week, how many hours in the week. Yes. But here I will set, for example, 24. For example, 24 hours. No, I will set lower value. Let it be 1 hour. 1 hour now. It's very difficult to type on this keypad. 1 hour. And last parameter of this buffer is type cyclic or end.
And
Yes. Cyclic or end. What that means? It means it's very simple. It measures first value, it records first value, second, third, and so on, so on, so on. And after, for example, 24 hours, if we set cyclic, after 24 hours, it will delete first value and write new last. So it's really cyclic. It stores it infinitely, overwriting the oldest value. So every time it has, in this case, every time it will, or any time, it will have last, in our case, 24 hours, yes. I said 1 hour. So it can measure values, it can register it, for example, 10 days, but anytime only one last hour of data will be stored in memory. And if we set end buffer, it will store it the same time, for example 1 hour, and then it stops, and this data, which is set for buffer type A, memory type A, this data will be stored, so it will be only the first hour from the point from the moment of starting recording. When we use each of these two types, if we need, for example, if we need to get data for some specific time, specific process, for example, at some plant or some factory, they they are going to perform melting operation of some great furnace, and it can get, for example, 1 day or maybe 1.5 day. It's a real situation. So in this case, I can set up, I can connect analyzer to network. I can set up measuring time, for example, 2 days or 24 hours. Yes. But maybe I connected it, for example, at the Monday, or maybe even in the Sunday, in the holidays when nobody works and when all installations are disconnected, and it is more safe for me at the connection process. So I connected it. I set it for 48 hours, but I'm not sure. Could I come to this plant, for example, Monday, Tuesday? Could I come in the Tuesday evening to stop monitoring, to stop recording, and to get data and to disconnect this analyzer? Maybe I will have free time only in the Friday. But in this case, I started monitoring, I started recording. It will record. If we use cycling process, in the Friday I will see only data recorded at Thursday and Friday, when this furnace did not work. So I will have 0, 0, 0, 0, 0. It's very useful data. Yes. So in this case, it's better to set up end buffer, end memory. So it will start measuring, and after 48 hours it will stop, and this all this data will be stored, and it will wait me until Friday, until Saturday, until next month.
Okay.
In this case, the main point is to not disconnect it from network, from power, because of course it has battery, but of course
One day.
battery is not infinite. So I think it also now battery is old, so I do not know if it can work from battery 10 minutes or 20 minutes or maybe 5 minutes, maybe 1 hour, I don't know. But I do not like to perform experiments on it, of course, especially when we have important data inside of its memory, because it's bad idea to lose all measured data, especially if we do not know when we can repeat this measurement.
So it means for modern equipment, they should be able to save that data for you. Whether there is no power supply, for modern equipment, they should be able to save.
Yes.
Okay.
But this one does not have any type of memory of energy independent memory. Yes.
Okay.
So it will reset data if it will be disconnected, and if battery will be discharged.
Okay.
Yes. Well, in this case, it's better to use end buffer, end memory. But cyclic is very useful when we need to catch some event. What I mean, once again, examples from real life. We have some sudden events occurred in the network when For example, automatic switch disconnects network suddenly. For maybe once per day, maybe twice per day, no more. So, and nobody can say when it will be next time. So, of course, we can set it to measure, for example, 3 days, but in this case, to analyze and to find what is the reason of disconnection. For this reason, we need to perform measurement with the maximum precision, with the of course not with the meantime 1 period, because we can get some impulse, some notch of voltage shorter than 1 period. So if we will measure every minute, for example, we will not see it on the diagram, because average, even if this impulse is high, but one impulse during 1 period, averaged at 10 minutes, will not be seen on the diagram. It will be very low. Average value will be almost normal. So we need to perform measurement in this case with maximum precision. But if we will measure 3 days with 1 period meantime, we will get insufficient memory of it, because it's very great volume of data with so short mean time. So what can we see, what can we do, and what we did in real life? We set it as a cyclic buffer, for example, with length about, for example, 3 hours, only 3 hours, not 3 days, and with meantime 1 period. So every time we have last 3 hours with very high precision of measurement, and we simply asked some personnel to if this event will occur, please press stop. So analyze it, measure and records voltages and currents at all 3 phases, 1 day, 2nd day, and for example after 2.5 days this switch disconnected, this event occurs, and all we need that somebody press stop, and after he pressed stop, recording stops, and we have for example 3 last hours. Of course we need to know if there is somebody in this, for example, in this workshop or in this enterprise, maybe we need to set not 3 but 8 hours. In this case, even if this event occurs in the night, we can come in the morning and stop it to be sure that necessary data, recorded data, is stored in memory. So if we don't know how many time we need to wait for the event, we use cyclic. If we know time when we need to start and when we need to stop, we use end type of memory. And for another buffer, for another memory, we can set another mean time. Let it be 10 seconds or maybe 1 second. So it is 50 times longer. Yes, mean time. And length, let it be the same, 1 hour. So we will have different data at different stored with different frequency. One of them, of course, both are stored during 1 hour, but one of them is stored every period, but another parameter is stored
1 second.
only every 1 second. Yes, and so on and so on. And there is a specific type of memory is D. D is set for yes, because it is made for registering waveform like oscilloscope. So of course it cannot because of its memory, it cannot register waveform all, for example, 1 hour. 1 hour of oscillograms of waveforms, of voltages, of currents. It's once again, it's a very big volume of data, and they are not necessary. We do not need waveforms for 1 hour. We need to see waveform if some event occurs, like disconnection, like voltage dip, like some impulse. So it is set like a number of events. For example, 10 events.